Welcome to the video of crown router doors. I'm going to be talking about various types of crown and raised panel doors through this series. There are actually two styles that we're going to look at. One is what we call an arch top, and the other is what we call a crown top. Now, as you look at this door, it has an arch at the bottom and a crown at the top. As you see these doors throughout the video, you're going to learn a number of things. First of all, if you look around behind me, in front of me, we have all of these jigs and fixtures that have been designed strictly for doing arches and crowns. These are the tools you're going to need, and we're going to explain throughout the tape. I thought I'd show them to you now to give you an idea of the magnitude of what's here. You'll need to really watch. You may want to back up and see things a couple of times. As we go through this video, I want to suggest one other thing. This builds off previous videotapes in the sense that the knowledge that you need to do these isn't all in this videotape. What I'm saying is, if you haven't made a video or if you haven't made a door with straight panels like that, you should do it with the straight panels before you do a crown or arch top. The reason I say that is there's a lot to know, and you shouldn't put all the challenges in your first project. Learn to make the straight ones, then graduate to this. It's a logical progression and something I'd urge you to do. That way you'll have thought out everything you need to do. Now, let's talk a little bit about things. As I mentioned, this is what we call an arch. This is what we call, this is the arch, this is the crown. I'll get it right eventually. As we look at these two, they're both what we call rails. And how do we know the rails on a door? Well, the rails run parallel with a railroad, and it's a simple way of learning it. What are the vertical pieces called? They're referred to as the stiles. There's no stile in them like in clothing. It's an S-T-I-L-E. Let's take a look at this door when we separate the parts. The stile has one cut along the inside edge. The rails have a cope cut on the ends and a stick cut on the edge. This is also known as a stick cut on the stiles. Now, some people, to make it a little more convenient, refer to the cutters a little differently, and what they do is they call this a rail end cutter and a rail edge cutter. However they're referred to, those are the cutters that you'll need to make the frame. Once you've made the frame, you'll be making up the panel, and the panel then that we'll be working with will be 5/8 stock, and the ends have been sanded to a nice true arc to make the door up. Well, these are a few of the things that you need to know. You'll hear these terms used often. Once again, this is the crown, this is the arch. I did get it right once. As we look at these parts, we realize there's a number of cuts to be made, and there is a logical progression. I'm going to show you that logical progression as we go through. But let me also talk about some design considerations. First of all, there is a factor of equality here that we look at. That is to say that if you measure across these stiles here and rails here, they're obviously different in width than the crown rail you see here. But what you will come to notice quickly is that the width of this rail at its greatest part is equal to the width of this rail at its least part. Now, that gives us a look of proportion when we look at the door, and that's one of the first design considerations that you want to think about. The next thing that you have to do is make sure your layouts are all accurate. You may have to make up, or you will have to make up, a pair of templates either for arches, and these are a 12-inch radius, which is typically what I use, and here is the crown set. The crown set has the center lines marked with a saw curve, and they're just about a perfect mate. The crown actually goes up approximately 2 inches, and it's about 6.5, 7 inches wide. It has a nice graceful arc here and a nice graceful arc here. And what that does, it allows us to get this profile. One other thing that's important is generally they start with a flat and come up. They don't just start at that arc and come up. We need a little bit of a flat there, and we'll explain more about that as we get into the videotape. So be very accurate in making the templates. They are what control all your dimensions and all your cuts. Now, one thing that I'd save till the end, and I think it's important that it is at the end because now you're listening. Safety. There are a number of things that you want to think about. First of all, use guards and push sticks for all of the cuts. You'll see me demonstrate it, but don't think that it's not important. It's very important. Second, wear some kind of earmuffs or other hearing protection to protect your hearing. A dust mask, protective glasses, they're all real good. Dust collection at the router is another important thing that you can do. Controlling that dust and that buildup is good. Your lungs should not be the dust collector. Disconnect your router from the power source whenever you're making adjustments. Another very important thing to do. Never take chances. Always spin that bit while it's disconnected to make sure it's not going to hit any of the jigs or fixtures that you have aligned. And keep your router speeds low. When you're using a raised panel bit, the type of bit that cuts this profile here, run it at 10,000 RPMs. When you make the cope and stick cuts, run those at 13,000 RPMs. You're going to need a router that has about 3 horsepower and is variable speed. There are many, many good routers out there, and as you watch this tape, you may better decide what you need for your uses. I'll be telling you a few tips about those as we go. So imagine right now you're thinking, am I ever going to cut a board? Yes, I am. Let's start with the rails. We'll go over to the router table I've set up and we'll cut those rails. So we'll go over there right now. We're ready to do some rail and stile shaping. We're going to do the edge cut, which is known as the stick cut. I've prepared my stock, and one of the things you have to remember when working with this is that the good face is down. So before I cut it, I want to spend a minute or two showing you a few things. We've got a dust collection system built in here to remove the chips. I've actually got 2 3-inch hoses going into a 4-inch dust collector. Beneath the router is a scoop like this that I've made up, and we just caulk this in, and it's good and solid, so it's pulling the chips from the underside. A nice feature, and we're going to try and work as safe and dust-free as possible in this tape. Also notice this feather board here. It's a spring-loaded device. Those holes that are drilled here, there's a bandsawn line that comes to them. So what's happening actually is there's some spring to this. So it's kind of a holding device as well. We've bandsawed a slight arc behind here because of the ball bearing of the router bit. We want to clear that. If we had any portion of that, we would be seizing the bit and we could burn the edge. So that's why that is there. I've also taken one of these Jointech polyethylene feather boards and set it up here, and that'll hold the stock as it goes through to hold it in position. So all of my rail stock is ready, and stile stock, I cut it in lengths of about 3 feet. You can cut it any length, 3 to 5 feet, 2 feet, depending on what you're doing. In some cases I'll cut smaller pieces for my rails, and that's fine too. These I can cut according to my bill of materials. So once I've set up, I've got a push stick and so forth here, I can make this cut. That's the cut, and you may want to look at these. One of the things you'll notice is that that edge is just uniform along there. It's about 1/8, and what it means is that this groove comes from 3/8 to 5/8 down, and that'll be important later. If you have more interest in that, you might look at my video 205, which will tell you more about the details of this. Let me show you one other thing that we'll have to do later is we'll have to cut the edge on the rails if we're making an arch. What's an arch? This is the arch top here, and if we're going to cut this later to a curve, first we'll make the cut on this edge. And the reason we do that is so that we can get a purchase on the shaper table when we're doing freehand, or router table I should say. Now, once these are cut, we'll just have to change the setup to do that. We'll go to another router setup to do some coping of the ends of all the rails, the 2 1/4s as well as the wider stock. So I'll meet you back here with a new setup, and we'll proceed with that operation. I'll get the stock cut. Meet you back here in a second with a new router table. I've got my wide rail, which will be a crown rail, and I've made 2 cuts, the coped ends and the stick edge. Now, this rail will now go to be cut like so to get the arch in it. And it's a little smaller, and you're going to have various sizes depending on your doors. This cut, or this arc, will be cut afterward. We need to have a little bit of material there to start our router, and I'll show you that later when we get into actually making the rails and cutting the profile and the crown. But for now, that's the most important part. Now, with every one of these rails that is a crown at the top, at the bottom you'll have another rail that's the same width as the stiles, 2 1/4 in this case. We've got to cope it as well. And if you're experiencing tear out, and you probably will with a setup like this, you can plug a block of wood in like so. And this is really just a piece of stock that was cut with a mating profile, coped, and then ripped off a wider strip. Now what that does, it acts as a backing board to control tear out. I'll demonstrate that and you'll get the idea of what's happening here. Notice there's hardly any fuzz there, and if you start to get fuzz or you had to make a readjustment, you can cut a little bit off here and it won't be a problem. Now I'm going to do the opposite ends. And do I need this now? Not really, because the tear out will be on the back, and this push block, notice how it's been profiled exactly the same way as the cutter. I'll make this cut and you'll get the feel of how both ends are done, and that's important. Then I'll take the guard off and show you a little bit about the setup so you see exactly what needs to be done. Now on this one, the tear out would be at the back, and notice there's just a little bit of fuzz. That's more than adequate. You can also make these a little wider and not worry about the tear out and slice them off after the fact. However you do it, just be mindful that there could be a tear out problem and plan that out. Now, as I'd suggested, I want to show you the setup, give you a little bit of an idea of what's happening here so you have a better feeling of how I made this operation work. I've got a false front on the actual fences here, and I've got a dust collection system on top that's removing some of the chips. Notice that I've coped that fence. I cut most of the wood out with a bandsaw, and then I slowly fed that fence in to cut away that material. That means then that I have contact along the center line there for the entire cut. In other words, that corner can't be pulled in because there's just not enough room when I have that square block behind there. And that's what the square block does, eliminates any tipping like so. This is a 2 1/4 rail, and you can do that successfully. If it were shorter than that, you may have some problems. If you got under 2 inches, I think that there may be some problems. So this technique may not work on smaller stock. What you would have to do then is use a miter gauge and maybe clamp the piece to control it. In any case, you can see that in my other tape, 205. I wanted to show you some different things in here. Now, we've got all of these cuts made on all of the parts, and we're assuming that. So now we'll go over to the bench and make this arc and show you how to profile that. So those are the next steps in the operation. I'm going to take these over to the bench where I'm set up to lay those out and make the cuts. See you there in a minute. Earlier you saw me make up this piece with the 2 cope cuts on the end and the stick cut on the edge. Well, that's the first steps, and remember I said this is real important. We're still going to cut this away, and I thought now I'd share with you that technique. First thing you do is find the center line of your piece on the back and make that pencil mark. Now what I've got here is a template that's used for both sanding and layout. Let me point out a couple of things. First of all, we've got a center line on it, and then we have some screws that have been driven through here, and we've ground them to very sharp points. These sharp points then will dig into the piece and hold it in position for layout. Now, what I've got to do then is I flip this over because I want the points on the back side. I'll bring it in, and what I want to do is line up the edges that have been shaped or profiled with the edge of the template, and I want that center line on the pencil line. Once I've done that, I give it a little push like so. and that would allow me to flip the entire thing over and keeping the screws in position. Now I'll make my layout line. I like a pencil that's kind of worn because I want a big wide line. In most woodworking we think of a fine line being better. But what we want to do is saw to one side of the pencil line and sand to the other side. So I'm going to blacken that in nicely, really work it, and that's what I need. Something that looks like that. That won't stay up because it's shaped, but you get the idea. Once that's done, we end up bandsawing it, and as you look at the back of this one, I think you can still see the pencil line and the center line. So you can also see 3 little holes that have been poked, or maybe you can't, but they're small holes that have been poked by those screws. So let's flip the jig back over, and we'll bring this over and kind of eyeball where we were. Yep, I found my registration points. This is now ready for sanding, and I'll show you that in just a minute. But let's now go from the arch, or I mean from the crown to the arch. The crowns come up like so. The arches are just a fast sweep. Now, I've made a couple of these up, and what I've done here on this width, as luck would have it, I've measured down 2 1/4. Where does the 2 1/4 come from? The 2 1/4 is the same width as all of the other stock in the door. In other words, the bottom rail and the 2 stiles are 2 1/4, so we want to match that. When I put my template on there, and this is a 12-inch radius template, I line up with the corners there. So I can hold this like so, and again I want a nice black line, fairly wide, work that pencil like so. It's okay in this case to have a wide line. Once that's been done, I then bandsaw this one, and again it's the same thing. We've removed everything but the pencil line. This allows us to do some sanding. Here's one that has been sanded already, and you can see that I followed that arc and I've got a beautiful sweep there. Now, what I've got to do here is I now go to my arc template, and it too has the screw holes in it. But since this is just a uniform arc, we don't have to be quite as concerned about positioning. So I'll just push that down now, and I'm leaving the pencil line exposed, which is good. I can then flip that over, and it's ready. Now both of these can be sanded easily. One other thing I want to show you though, not always do they come out to the ends of the piece so evenly. And so now I've measured down 2 1/4, again my rail width, and I've got 2 points that are coming up uniformly from here. In other words, so I'm not askew with my template. Then when I can put my template on here, my considerations are that I go through all 3 points. So I line up with that point, and I watch these 2. And when I get there, I'm satisfied that I'm on the money. I can then make this layout and bandsaw this one. And again, this is a 12-inch radius. All right, so all of this is set. I feel very comfortable with what we've got ready to go here. These templates will be used. Now let me show you my drill press. A few things. It's a smaller drill press, but it's real handy for what we're doing here. I've extended the table to give myself a little larger control surface. I've got a drum sander with a ball bearing type device on the bottom. And what this allows me to do is sand to a template nice and true. Now this is roughly akin to this, isn't it? A laminate trimming router bit. It too has a ball bearing. And the question some of you may be asking is, why not use this? Well, what happens is as this bit comes around here, what kind of grain is it into right here? What's happening when it gets right here? It's taking the end grain and could tear it out. At this point you've got a lot of time invested, and that's not the way to do it. It's much more efficient to sand it, not have any tear out when you go to the router table to make that other cut. So all of this is really done to make the job easier in the long haul. It may seem like more now, but it's worth it. These sanding drums are available from CMT out of Oldsmere, Florida, and they're designed just like that. There's 3 different sizes, and I found this size to be most compatible with what we're doing. I've got my drill press set at about 3,000 RPMs, which is efficient for sanding. I'm going to sand up a couple of those and go through the demonstration of that so you see what happens here. Okay, I've sanded real nicely. I've got a nice line around there. I know that my router bit will follow that, and the profile that will be up here will match that smooth curve and leave me a real nice arc there. The technique is the same here. It's a matter of engaging and feeding against the rotation. I'll do that real quickly. We'll take a look at what it's going to be like, and then we'll proceed with some other operations. You'll want to take light cuts and keep the piece moving. If you get burning, that indicates you're moving too slowly. Now this cut looks real good. It's nice and uniform. We've got a uniform radius there. If you do experience some burning, your abrasives may be loading. You can use one of these abrasive cleaners to eliminate that. Now, we've seen the crowns sanded up. We've seen the arches sanded up. This is the only way I know to do the crowns effectively. But there is another technique for these arcs, and I will show you that with a new setup. And I'm going to go get my router and some other materials. I'll meet you back here with that setup ready. I've got a router table, or not a router table, but a router fixture right now set up to make an arc on our rails. And as you saw earlier, we've coped the pieces. We haven't done the stick on the edge because we don't need to. That would only be on the crowns. This is for cutting arcs. And what we're going to do is mark the center of the piece, and you can see I've got a piece in there that is marked. And I've made up some rail stock that will fit our, well, stile or rail stock, but it has the stick cut and it matches the cope perfectly. And what this allows me to do is put some wedging action on this and not tear up my joints. Now, I've got some 1/4 bolts that are going through T-nuts into this jig. I've ground a sharp point on them so I know that they'll dig into these pieces. And as you notice, I tighten that up a little bit. I'm actually pushing that over. The center line is on the spot right now, so I'll put just a turn or two on here, and I may move it a little bit. Yep. And now I'll come over here and do the same thing. And I bet I move it back. So we know we're digging into that piece of wood a little bit. And I've been careful to tighten these all about the same amount. That's pretty tight. Now, one of the things I like to do is put an extra about half a turn to a turn on the bottom one. And what this does, it actually makes a wedging action. That is, it's pushing the piece upward into the jig so that it doesn't want to creep. If you don't pay attention, once in a while you'll find a piece creeping. And that's what happened to this piece. It was in here like so, and as I came around, the piece started to walk down. Now, I haven't had a problem since I started wedging this. But should you have a problem, what could you do to make this better? A couple of things you could do. You could glue a layer of abrasive in the inside of here so that we're actually resting on something a little rougher instead of that smooth stock. Or you could put a couple strips of double stick tape in there and push down on it as well. And that would also resist that creeping. Now, this isn't something you make in one pass. This is actually done in about 3 passes. And it'll come across here like so, using a plunge router. I've got a 1/2-inch spiral bit on here, and the distance from the bit center to the pivot point is 1 foot. So this is a 12-inch radius, and it will cut nicely through the stock. With this setup, I usually start with a blank that is about 4 inches wide. This one, if you can't really see the path, but I'll actually take out a little bit. I'll actually leave a little crescent-shaped piece when I'm done, and I'll show you that when I've completed the cut. All right, so I'm going to do this in about 3 passes. And that's the approach that I choose to use so that it is safe, and I'll just plunge down. So I'll make the 3 cuts one right after another, and you can see this in action. Now I'm going to drape my cord off the back here so it doesn't get in the way of my work. And I'll let that just drape down, and I can plug it in now and proceed from there. Grab my muffs, position myself, lock down. There's the first cut starting to outline the shape. When we come across here, we're actually cutting end grain, so we don't want to take too big a bite. There's the crescent-shaped piece that I was talking about. That forms the exact radius that we're going to be working with. And let me take this out and show you the cut so you get an idea of what kind of quality we get. Now I've got this triangular block I just put under here to kind of support the router. Take those off, and you'll see that the cut is really nice, even going against that end grain. And part of that, I suspect, is the fact that we're using a spiral bit and we're getting more of a shearing cut. I don't think I'd want to use a straight cut in that end grain, a straight cutting router bit, I should say, in the end grain. Now, 2 or 3 of these can be linked together as they were here with a couple pieces of plywood, and that forms a perfect template for laying out any other mating arc. So you can use them that way as well to make up a template. Well, you've seen a number of ways of getting these arcs and crowns on the pieces. I think now it's time to actually put a shape on this. So I'm going to go over to the router table and get that shape set up, and we'll then cut it. So I'll see you at the router table for that setup. We've set up a jig here to do the stick cut on an arched rail, and what we've got here is an arc that matches the arc on our arched rail. We can use this as a fence now, and it'll follow around. The ball bearing on my cutter is aligned with the edges of that arc. So it's in a perfect orbit there as this comes around, and that'll control the depth of cut. And we've checked to make sure that we've got clearance on both sides of the bit so it won't jam in there. And what we'll do here to make this a little safer is we'll add this barrier or guarding system. I've got a couple hanger bolts here, and I've got dust collection as well. As I tighten these down, put a pair of washers on, tighten these down, and this will limit access to the cutter, making the operation a little safer. Now, as you can imagine, this jig took a while to build, and part of building anything with the arches or crowns is that you're going to have to take some time to make the jigs, because if you don't put the time in early, you'll spoil the job. Let's see how this works. Get my muffs. The bit height is just about perfect. You can see on this side the cut left just a feather of wood. Over here there's just a little bit more. There might be some deviation in the piece, but for any work that I'm doing, I'd be really pleased with this. Now, with certain small pieces you may not feel comfortable using the push sticks, so there's another technique I'd like to show you here, and I'll get ready for that real quick. This is the handler, and it is a device that you can buy that will allow you to shape stock. Now, Obviously, I can't quite get under this barrier guard, so I've prepared another one, and I'll put that on and show you this operation. This will give you another idea of how it might be done. Again, we don't want our hands on the cutter. We always put a barrier on. We want to work safe and work smart, and that's part of what this video is about. It's educational, but it's also showing you the safest ways I know to work in woodworking. This barrier is a little higher and a little smaller, but our hands are still quite a ways away from the cutter, so I feel very comfortable with this operation. And again, depending on the size of your work, it might influence how you would do it, or what equipment you have too might be a factor here. Okay, so I can just get a feel. Feels right. Comfortable with that. Make sure that this is locked tight. It is. Okay, so I've got sufficient clamping pressure. It can't wander on me. Let's go ahead and make this cut now. Once again, I've got a very nice cut. One of the things you have to remember working with this is your good face is down when you make this cut. Good face down with all the router bits. So keep that in mind. If you've only made enough pieces to get the job done, what you're going to find is that you'll be back to square one building some more parts. Of course, the alternative is to make a few extra parts in case that happens. But a lot of times you'll find me writing something like GFD, good face down on the jig, so when I look at it I know that I'm right. Now, that shows you the arch, but how about a crown top? This obviously isn't the jig to do this. And we're going to use the same profile, but we're going to have to change our setup here. So what I'm going to do now is I'll pull this off and I'll come back with a setup to do this arch. And I'll meet you back here in just a minute with a new setup. This probably looks a little like a bathtub toy. It's really not a boat, but it is a device used to act as a barrier to keep us away from the cutter and also as a dust collector. We'll be working freehand, so we'll use this to kind of limit access, but we've cut it back on the side so we do have room to get at the bit, and we need to do that. We'll be using a fixture. It's a freehand that runs off the bearing of the cutter, and so we make sure the bearing is free, and we also make sure we have clearance around the bit so it spins freely. This hole that was drilled through the top is actually larger under here, and that allows the nut to be raised up in there, again limiting access. Double check your clamps. This should be down snugly, and it will be used with this setup too, and I'll show you more about how this is used. This is a stop block, and I'll show you how that's used in just a minute. But before that, I want to show you something. This was in the jig, and you'll notice that when we came in, the first thing we caught was end grain. And this was pulled right out of the jig, and you can see what's happening. It's just grabbing that end grain. And you recall earlier that I said if you're doing crown rails that you wanted to cut this stick cut before you began making the arch. After you make the arch, this is what remains of the stick cut, and this is all we're going to cut. Now the beauty of this system is we're going to be working safely, and when we bring this in on the bit, it's going to be in the cut area, which is more like edge grain than end grain, and it makes it much safer. But you should have a flat on these if possible. If you don't have a flat, you can cut these even on an 8-inch and you'll have a starting point. The other reason you want to do this is the ball bearing doesn't engage until it gets on this flat here. So it could cut and make a little bit of a snipe out of that decorative molding, and you'd lose that nice fit. So these are the reasons that we're doing what we're doing. There is a rationale to it, and I think it's very important that you grasp this now because it's all part of this. Now let me grab the jig and show you what's next. This is the jig. It's got a center line mark on it, and notice that the center line mark we'd use to make this crown is lined up with that so that we know we're pretty well centered on here. We've got clearance under here so that the bit will not catch the jig, and that was designed that way. This is 3/8 plywood with a piece of about 60 grit abrasive on it. The 60 grit abrasive makes it a lot stronger for holding, yet it doesn't damage the face of the workpiece. Again, the good face is down here, the bad face is up, and we can see the marks that we had from actually making this arch cut. Now, this will go on like so. Will actually be positioned like this. I'll be standing here, and I'll bring that in. And notice that the ball bearing is touching. And the reason for that is we've made that stick cut on the flat edge. This allows us to get on our workpiece without a problem. In other words, we're not cutting when we begin. And that's an important aspect of this. Once this jig is made, again, there's a lot of time invested, but this will last and it will do the job, and we're going to see that action right now. Okay, there's the cut, and it follows the crown just beautifully. We've got a real nice fit there, and that's what we're after. So when you're working with this jig, this is the kind of control you're going to have. Notice that when we got into the middle, we needed that clearance on both sides, and that's why it's cut back. We talked about that earlier. This is ideal, it's safe, it's comfortable, and that's how I want you to work when you make these crowns and arches. We're going to move on now to start cutting the panel stock and show you how to dimension that. So I'm going to be meeting you at the bench with some of those setups here shortly. See you there. I've got my frame assembled, and you can see I've got a crown top in the frame. The frame is the perfect size for the opening, and I'm happy with that. The next question that you're probably asking is, well, how do I determine the size of the panel? And that's a good question, and it's one that's often asked. Notice this ridge around here that's formed by the profiles that we've cut. If I measure across like so, I can get the width of the panel. This says 10 shoulder to shoulder. I would say 9 7/8 to 9 3/4 depending on the season and how much wood movement there is. The actual absolute height can be determined this way, from that bottom shoulder to the shoulder right here, and I'm getting about 15 3/8. I'd probably make the panel 15 1/4. So once that's done, I can then cut my panel to the rectangular shape, and that's what I've done here. I've got it so it's the right width and the right height, but now I've got to lay it out. To lay it out, I first find a center line on here, and I've got that marked, and then I've come down with two marks here that are, I believe, 1 7/8 inches, 2 inches. That leaves the 2 1/4 rail. So I come down the 2 inches, and I'll still have 2 1/4 when I shape the profile. Next, I've got a template that has the crown on it, and notice that it has some screw points in it. Those screw points will dig into the piece. So what I've got to do is I line this center line up with that center line, and I line these two shoulders up with, or these two shoulders with the pencil lines on the edge. Once that's done, I push down. This is done on the back of the piece. So I've got the center. Now I've got to kind of turn those. And it's about right there. I better come down a little bit. That looks good. I just push that. I can hear those screws digging just a little bit, and that's just what I want. Now I've got a pencil with a little worn down lead, and that's good. I'm going to mark this, and I want a good wide black line, because a wide line gives me plenty of room when I go to bandsaw, and that's important. So there's my layout line. The next thing to do would of course be to go to the bandsaw and cut that out. And I've done that, and you'll notice that I've left the layout line. Now earlier in the tape you saw me do some sanding, and I actually put this back on the template piece, and you can see where the screw points were, and I've got just a little bit of pencil line left, but look, I've got a beautifully sanded crown here. And so now I can test the fit, drop that in the opening, and I'm good. So that's the way to determine your size. Now with an arch top, all you do is find the tallest point again and set your arc. Nothing to it. Alright, so that's the steps that you'll focus in on there. Now, in laying out the arc top, there's a little bit different method. And what's going to happen here is I've made my template up and I've got a very fine center line on it. And I'll put that center line on the center line of the panel, and I don't know if you can see it from here, but let me point it out. I've got a nice center line formed there. I'll bring that up until those are aligned. And now what I'm most concerned about is that I might get askew like so. So as long as I'm on that point, I can take a framing square or tri-square, any squaring device, bring that up, and then use that as a positioning device, like so. Now I know that the two sides are exactly the same. So let's take that coarser pencil now and really lay into that. Get a nice wide line. And once again, we would bandsaw that off. And what would we come up with? Well, we would come up with this pencil line that you see here. And there's still a little bit left, and we can then proceed to sand it. So once we've got that set up, it's a matter of sanding. Now, a little refresher, you saw this earlier. We got a ball bearing under here and we got a spindle. All we got to do is let the template ride against that. And so what we would have seen is something like this. This would have been positioned on here, and then the sanding would have occurred just like this. And you can see I can just barely move that. So I've done a beautiful job of sanding. Once all of that is done, and it doesn't matter which template you use, it just depends on what you're making, you then start to think about raising the panel to get you a door that looks like so. And speaking of panel raising, I think it's time we go to the router table now and actually do some panel raising. I've got a lot of interesting techniques I want to show you. I'm going to meet you over there with the first setup. We've got a new setup here for cutting the top or the crown of a panel. What I want you to take a look at here is first the panel bit that I have in here. This is a CMT chip limiting panel raising bit. The chip limiting is the small opening or gullet here, which resists or reduces the likelihood of kickback and makes a smoother cut. For hand feeding, this is the best type of bit. CMT makes a real fine one, it gives a real clean cut. You're going to see that in a minute. There are other fine ones out there, but you want a chip limiting bit. That makes it much safer. How do we set this up? There are two things that we've done. First, we've made sure that the bit is clear all the way around here, that we're not rubbing on anything. And then the next thing we've done is we've aligned the ball bearing with the arc. And this is my master template that I've used for everything so far. And I put that in here, and I can feel that ball bearing rolling just slightly, and I'm touching out here and here. I've got a nice fit. And so that's the way you get the bearing in that arc, using your template, your master template. And you'll notice this template was sanded smooth. It's really the arc, and this is the master that we use for all of the parts. Next, let me call your attention to a holding device and a barrier guard that's going to go on here in addition. This has the featherboard technique here where I've drilled the holes and made a bandsaw and cut to them. This is designed for a 5/8 thick panel, which is what I favor in my work. That allows me to glue up and plane down. Glue up 3/4 inch and plane it down to 5/8. Now, this sanded out a little under, so what I'm going to do is I'm going to put a little veneer behind each of these hanger bolts, and when I set that on, it'll kind of tip this down so I'm getting a little more engagement. Put my washers on and then tighten this up with my wing nuts. Alright, so now I have a very solid setup, and I have control. I can't get into here, and my piece will actually go under there, and I'm getting just a little bit of resistance. I can feel that. Just grab. You can see it going up and down if you look real closely. See how it lifts there? So I've got a little bit of downward pressure, not enough to pinch. This will start like so, and I'll ease in. I'm taking a light cut, And a light cut is important. You want to work safely, even with a chip limiting cutter. This is something you'll do in 3 to 4 passes, depending on the thickness of the stock, the sharpness of the cutter, the type of router you have, and the hardness of the wood, of course. But 3 to 4 passes is realistic. Don't try to hog, don't force it. You'll just end up with tear out and you'll ruin the pieces. Right now you've got a lot of energy into gluing something like this up. It's just pointless to not take your time with it. So let's show you the cut now and see how this works. Now that's a light cut. It's a good cut. You can see that I've got just a slight burn there, not even enough to turn it brown. I was feeding slowly. You'll notice the slight hesitation when I began. That hesitation was getting on the ball bearing. It's not a problem. You just, once you contact that, you begin the cut. There is a little bit of tear out on the ends, and we've wandered just a bit here. Is that a problem? No, because when we put the straight cutters on, the straight fences on to cut these sides, we'll clean that all up. So we'll bring this down to size. Now that's my first cut. I would say I'm going to make 2 more cuts to get this to thickness. And what I'm going to do now is I'm going to continue cutting, get all my panels ready, and I'll meet you back here for the final cut, and you can see how we test to make sure that tongue is the right size. So we'll do that. We'll meet you back here in just a minute. You've seen this. You know exactly what I'm going to do for the next pass, and we'll make the final cut for you. Be right back. We've made a couple of the passes already, and we're down to the final pass, or we think we are. We're going to test the fit and see. So let's make that cut. I think you can see that we've got a nice shoulder forming around here. Very little tear out, so we've done a real nice job, and that's what we're after. Good quality. Now the true test of the fit is actually your rail stock, and that fits just a little snug, and you want to test at 2 or 3 spots because you might have a little warp in your piece. I would probably take another cut, or I'll tell you what I'm going to do. I'm going to go ahead and make the same cut at the same height. I'm going to push down just a little harder and see what happens. That's a little better. I still think the fit's a little tight. You don't want to break it. You notice they come in here, it's loose, and you're going to find a little randomness as you go. So check a few places. That's the only tight spot in the center there. There might be a slight warp. I think I'll stick with that. I could always sand a little bit off here if I had to. That would be better than having all the panels rattle. So that strategy is one of those things that you'll have to work out on your own. You can use this as a gauge. You don't want it so tight that you'll break off the backs of these frame rails, but you want it so you're not going to hear a lot of rattling. That is just about right there. And you can see there's a little variance here. That's how wood is. If you wanted it perfect, you'd have made it a plastic. All right, we're set on this. I'm going to show you a couple more panel raising setups here in just a minute. I'll be back here shortly. I've got my setup now ready to go, and I've got a new jig here. I want you to take a look at this. First of all, I made a plywood box to remove the chips, and I've got a Plex shield up here so I can see what's happening. This allows minimal access to the cutter and allows me to get my jig and fixture in. Now, That's very important. There's another jig that you'll see here for the first time too. This brings in compressed air at somewhere between 80 and 100 pounds. The regulator holds it at 80, and when I turn this on, it sets up a vacuum in this wooden fixture I've made. Now notice there's like a weather stripping around here, and that assures a tight bond to the piece. The vacuum comes in through here. This is 7-ply or 9-ply plywood, so it's very tight. There are no voids in it, and that's what you need. Also, should you get one of these, and they're available from Woodhaven out of Davenport, Iowa, you'll find that you need to follow their directions as to the number of square inches of vacuum space on it. So these are all important. Just as a quick demonstration, let me show you what happens. I'll put this on here, and you can see it almost forms a suction when you put it on. So you push down lightly, and it's virtually impossible to get that off. So it's a very safe setup, and it's designed to get my hands clear and also hold any irregular profile. Now, a few other things before we start. The RPMs of this bit, since it is so large, it's that same CMT chip limiting bit you saw earlier, is set to run at about 10,000 RPMs, the lowest speed on this machine. And that's important. We've also set it for a very light cut. We're only going into the wood about 1/8 inch. What will happen is this. This stop block is clamped here securely, and it's going to allow me to pivot in to the cutter. Now, when I do that, I'm going to hit that ball bearing right there. And that ball bearing will allow me to roll through and make the cut tangent to that. Now again, I said I've got a light cut, so that's an important aspect of it. Once I begin that cut, I'll roll through and complete the cut and pull out. This will be attached, and you'll see that in a minute. But that's a very important aspect of it. Now I want to show you something else that helped me learn this system, and that's this board here. How's that for a raised panel? Would you like that in your kitchen? Probably not. But the idea is I've got a 5/8 piece of plywood that's virtually inexpensive compared to this oak that I've glued up and prepared and sanded. So this allows me to learn the system without wasting a lot of time and effort. I can cut this into profiles or shapes about ideal to what we're doing or similar to what we're doing, so I can mimic the situation and understand better what's going to happen. This was cut in 3 passes, I believe. It's a softer plywood. It's just a fir plywood, so it went well. If you do this, be on the lookout for voids like this. You want to make sure there's something for your ball bearing to roll on. So that's something to be thinking about as far as planning the operation. Now, also, I've unplugged my machine, and I've done that for a reason. I want to make it safe. And I want to show you one other thing, and that is this. You notice that I've cut around here. I've used the square or straight fences to make these 3 square sides. This was done with a typical square fence setup, as you would have seen in my 205 video. And if you're interested in that, you can take a look at that. It will give you a lot of information related to other terminology and things of that nature, how to plan it out. Now, when I said I want this to come in here, one thing that's very important is that ball bearing catches on something. As you notice here, I've already cut that down to a very thin line here, and I brought it into the edge, and I intentionally did that to show you something. That will ride over the bit if I'm not careful. So what I'll do now is I'll move in about 2 more inches, not 2 more inches, about 2/4, a ½ inch. So I'm 3/4 in from the edge, and you can probably see that if you look down through the plexiglass. This allows me to loosen these clamps up now and bring this forward, and I just ease this in because I don't want to disturb my piece. I know exactly where I want to be. There we go, disturbed it anyway, but I'm on quite a bit of wood now, and I know that bearing won't sneak off, and that's an important aspect too. All of these are important issues to look at as you go through. Now, I think I'm set. I feel comfortable with this. Let's plug my machines into the master panel here. Get the cords out of the way. Get that position. Grab my muffs. Let's see how that's going to look. One final test. I know my bit's clear, so I'm in good shape. Let's lock this down, test it to be sure. What you see now is just that first cut forming. And that's a light cut, and that's just exactly how it should be. I can take 2 more passes until that lines up, and then we'll have this appearance. So that will be the next 2 things that I need to do, is take a couple more light cuts to get down there. All of these are things that you have to work safely on and work smart. When I came to the end of the cut, I wanted you to note something else. When I got to the bearing at that corner, I pulled away. That's all you have to do. If you felt that the cut was too deep here, you can pull straight back. That'll disengage you because of the profile. You'll be lighter and lighter as you pull out. So if you ever feel like you're in a jam, that's the best way I know to get out of there in a hurry. Just pull straight back on your fixture. All right, well, that concludes this demonstration and technique. There is one other technique I'd like to show you at this router table that uses a little different system, and I'll be back with that setup to show you another way of going about it. So I'll see you back here in just a minute. I've changed this setup only slightly, and what I've got here is a pair of fixtures. These fixtures are designed for holding the panel. It's not a vacuum system, it's a little lower tech, but people are often asking me, how can I do it as inexpensively as possible, and this is a way of doing it. I have 2 sizes. This is a 12 and this is an 8.5, and they typically serve my needs well. I can add shim stock on either side, and I've even gone down to a piece of veneer a couple times to hold the pieces in. Let me set this off and talk about the other one for a minute. We have 2 shims, one on either side, to hold the panel in. The panel is extended over 2 inches out, and we know that the raised panel cutter will only cut about 1 3/4 inches, so I know that the bit will not touch or contact the jig. It's in there tight. These clamps, when you put them down, you want to hear that kind of thud at the end. That tells you that you've got a good tight fit, and always check them. It doesn't hurt to check them at all. All right, so that's the first thing that you need to be aware of. Second, there have been no cuts made on this panel yet. We're going to use the same stop pin, and you remember how we did that? A little test. We locked in here and we brought the bearing in so it's contacting the workpiece like so. Now, you'll hear a little bit more digging when this happens because we're grabbing some end grain and no cuts have been made. This isn't as safe as the other method, but it's safe. We're holding our hands well away from it. We've got absolute control, and we're taking a very light cut at low RPMs. Again, we're down at the 10,000 RPMs. And speaking of that light cut, because of the 3/8 thickness you see here on the underside of that jig, it means that the bit has to come up above the table. The only way the bit can come up above the table is if you have a 2-piece router. Typically, a plunge router will not allow you to raise it up. In fact, what happens is you want to cheat on the shank of the bit if you use a plunge router. I've got a Porter Cable 2-piece 5-speed in here, and I found that it does a wonderful job. I tell you this not because I have any stock in the company. I tell you this because if you plan to do these types of things, you ought to know that early so you can do a good job. Now, I think I've got everything set. My pin's clamped. Double check that. All of these are snug. Everything's ready to go. I'll pull this off of here for the starting position, get my muffs. This represents a light cut, and you notice how it pulled right onto the bearing as it contacted the end grain. There's a slight burn there, but as I go along and clean up the cut and make a couple of additional cuts, we'll be able to remove that, taking a very light cut at the end, which will allow us to breeze through there. Not only that, when I do the straight sides afterward, and you can do them before or after, what would happen here? We're actually going to cut that away, aren't we? So it's really not a problem. This is all that needs to be done. This is the same setup as you saw earlier. I would do all the crowns and then I go set up a square table to do the edges. And again, you can check my 205 for that. Now, those are a number of methods. I still have one more trick up my sleeve, and I want to show you that with a different router table setup. So I'm going to change things around and show you that in just a minute. I'll see you back here with a new setup. This is one more setup in working with crown or arch panels, and this is kind of the finale. This is a neat setup, and it works real nicely for doing all of the cuts. It kind of looks like a half a fence, and that's how it should look, believe it or not. This panel was cut already using this cutter and this setup. And I'll explain what happened. This fence is in alignment with the ball bearing, so as I come up here, I'm on the ball bearing as well. As I continue feeding, I get to this corner, and I then make this pass in here like so, working my way around, and then I come out here. I then bring it back, and I can make this straight cut across, and after I complete this straight cut, I can then come back, turn it, and make this straight cut. So all of these cuts are made with that setup. Now, we've got a Freud chip limiting router bit in here, and it's a little smaller in diameter than the CMTs you saw earlier. And that's nice, I can take a little bigger cut. But something I wanted to point out to you, if you have one of these adjustable rabbiting bits, what you can do is remove a lot of that material with that bit before you come to the router table. That makes it just a hair safer because you've got less wood to work with and less setups of the router. Now, I can't drop the bit any lower for a light cut because I've got a plunge router in here, and I'd actually start routing away the base of the plunge router. So the fact that it's a smaller diameter and a chip limiter doesn't trouble me, and I feel confident that I can make the cut. Now, what I haven't shown you yet is the barrier guard. Now, obviously, I wouldn't want to do this without some kind of barrier. And I've got dust collection. This is a rather fancy dust collection system. We've got a 3-inch galvanized elbow onto a piece of plastic rain gutter that was cut with 2 cuts on the bandsaw to make it fit on. It's attached to a couple pieces of maple, and it's just holding it in place. It's not going to go anywhere, and it's not going to touch the bit. I've spun the bit so I know that it's not going to touch the fence, and that's another good check to make. So now I can put my barrier guard over, and I've got a hanger bolt here, and you probably know that that's wood threads on one end and metal threads on the other. They're available at any hardware store. I have a T-nut in here that's actually metal threads in wood, and so when I put this on, I set that over the hanger bolt, and I can bring this flathead machine screw in, and I feel the threads engaging there, and I've got a little room for play here because nothing's that accurate. Next, I'll put that wing nut on, and that kind of brings it up rigid, and then we'll tighten this down. So now the whole area is clear, and I can't get my hands into the cutter, and that's as it should be. The design works real nicely. Now, as I mentioned, for the grand finale, what I've done is I've brought a panel that has a crown and an arch, or arc, whichever you prefer, on it. And so I'm going to start on the edge grain, and then I'll go into the end grain. So good face down. We'll start like so, and you'll see how it works. If I get into a jam anywhere, all I have to do is pull straight back and I can disengage. So watch what happens. I won't say it's going to work out perfectly. You know how things are in life. The best plan don't always work. So let's see how it goes. That's one side. Now, as I look at the piece, first of all, I can check my gauging to see how I'm doing. I'm not quite on there, although I'm going to make another pass at the same height because I see a little bit of a line showing here, but none. It's kind of fading out. So I'll cut it one more time here to make sure I've got the depth. There might be a little bit of a twist in the panel, and it's very true, but you never know, and I might have let up someplace. So I'll make one more cleanup cut, and then we'll readjust for the appropriate fit. Still a little tight there. Real nice around here. Just a little tight there. The end grain is clean. Now, I've got a slight burn mark there, and you might have saw me hesitate. I'm going to do these edges one more time, feed them through, bearing down a little bit, and let's see if we get it right. I removed a little of the burn mark. Still just a little tight. I think what I would do in this case is, since I have a little burning, I think I would just sand that a little to make it work. I see just a little bit of a high spot there. There may be a slight twist in the panel this way, and just maybe I can get that out. We'll try it one more time. If not, we'll sand. Well, the burn mark's going away, so I must have removed a little bit more. I think I'll sand there. That's good enough. It fits everywhere. That's the tightest spot. I'll be happy with that. Okay, so you've seen the rails and the stiles made, the panels made, all of the techniques and layouts. I think it's time to go back to the bench and glue one up and show you a few techniques there. See you at the bench. Well, I've got a door here all put together, and I thought I'd show it to you real quickly. All of the joints fit real nicely. This isn't glued yet, and it still fits together well. I'm really pleased with what I have here. And this represents exactly what I was hoping for all along. A nice fit, a quality job, well planned from the beginning all the way out. Now, if you were to glue this up, remember what you've seen in my other tapes. You brush the glue on, wet the wood, and then put it together, being very careful not to get any glue onto the panel or the panel area. This panel floats in here. You can actually see it moving, and that's good, because what that means then is it's free to expand and contract. You could pin this once you get it centered with a pin from the back side, like a 5/8 pin on the center lines, and that would allow it to move in both ways, out, expand and contract from the center line. In that case, you'll still have the movement, the door will fit nicely, and one other tip, you might want to stain that panel before you put it in, so if it does shrink, you won't see a white line along either edge. Now, all of this workmanship represents careful planning and good template work. All of the templates that you've seen me use throughout were laid out very carefully and very accurately. One of the things that's very important here is you spend the time making accurate templates. You can't make accurate arcs with inaccurate templates. If you flip your template over and it's different on the other side, it's not accurate enough. It has to be right on the money. So spend the time there. How do we get them this accurate? Well, you saw the technique of making the wide pencil line, bandsawing the outer edge, and then sanding the inner edge. Test them. Feel them. If they're bumps or ridges, sometimes you can smooth out a little bit. It doesn't have to be perfect, but it has to be very, very close. But don't allow any error to creep in the sense that it's got bumps or it wanders. Check it, flip it over. Is it the same? If it isn't, you've got a problem and you've been set up for failure from the beginning. Now, what I thought I would do is talk a little bit about some of the jigs and fixtures and feeding devices that you've seen in the video, and I'm going to spend a little time on that so that you have a better understanding of what is really involved. Let's first talk about two of the devices that are the most elementary, and these allow you to control stock very well and feed them. These are push sticks. In this case, I've used veneer plywood, and I've been very careful to cut them accurately, and I've rounded off the edges around here. I've taken a laminate trimmer with a round over bit, and I've rounded off the area where my hand fits. Now, that makes it more comfortable, but also were there a kickback, I wouldn't get any tearing or cutting of it, so of the hand, and that's why I put those radii on before I actually use these, and it's time well spent. Another device that you saw me use is this push block. Most people dread making up the handle. They say, well, I've got to drill it out and cut it by hand or something like that. But if you'll notice, that's not what I've done here. I actually came in with a bandsaw and cut this out, and I had to work at it a little bit. And you could drill a hole in the middle and then come in and spin around. That'll allow you to turn. Now, I just came back out that spot, and by putting 2 screws, one on either side of where it's been bandsawn, I don't have a problem. The front edge here, you can see, has that cope shape to it, and the reason it does is we've used it to push that. I've got a couple more opportunities to use this by cutting it off and having a new profile. If I wanted to use it for panel raising, straight panels or something, I could do so. This gives me a purchase and acts like a miter gauge for working with any of the router tables, especially when doing end grain. I've got control over the piece and I'm controlling my tear out. So making something like this up isn't as difficult as you would think. Also, I've rounded off all of the outer edges again, not only for comfort but for safety, and I would urge you to do the same thing. You also saw me use a vacuum jig, and with that vacuum jig I use this as my work holding device. The hole here was drilled to accommodate this brass fitting, and it's actually threaded in there. The threads are tight. I can't move it by hand. I actually used a wrench to put it in. I've used some 3/4 inch dowels to make the handles up, and I've rounded off the tops of them again. I don't want any sharp parts. When I told you that I had tight veneers in here, what I was referring to is as you look down this edge or this edge here, you see absolutely no voids or openings, which means then that when the vacuum is applied, there's no leakage. This is a very good piece. Certain types of wood won't work well, and if there's any type of perforations or air escape or leaking in them, they're not a good choice. So a large number of veneers and very tight, no void stock is the best. Baltic birch, materials like that are your best choices. Make them according to the specs. Make sure you have enough square inches of vacuum area to hold your piece securely. Don't scrimp on that. That has to be there to make them safe. You saw me use these 2 devices. One of them was to raise the panel on the crowned end, and the other was to shape the rail on the crowned end. Now, in both of these cases, we've got what we call toggle clamps, and you hear them snap down. There's a cam action that locks them down. In this case, they're vertical, and we could use them for handles if we wanted. Remember, we had the stop block when we brought that in, and we routed with it. In this case, we know we've got adequate clamping pressure. I've held these down with sheet metal screws that have hex heads, and the reason I've chosen those is if I want to use these on another fixture, all I've got to do is remove those 4 screws and move them to another fixture. A lot of people think they've got to have a couple of these for each fixture. You're only using one at a time. You can buy one set and use them on both jigs. The hole patterns are always the same, so that wouldn't be a problem. However you want to do it. We chose a couple sets. These snap down in our lower profile, but they wouldn't make very good handles. In this case, we used 1 1/8 dowels, and we drilled all the way through this piece. When you look at the end here, you'll see that I have a 3/4 inch piece on a 3/8 inch piece. The 3/8 goes from front to back. This is glued together. The dowels bottom out on the piece of plywood. They don't go through. Also on the face of this is a piece of coarse abrasives so that it'll hold the piece, keeping it from slipping. There's no clamping right now, but it's actually slightly embedded into the abrasive. It does no damage to the wood, but it holds it very securely. I've got a center line marked on here, and that's an important aspect of this, and I've designed this to clear the wood. If there were a problem, it's no big deal. You would actually just shape that wood away going with the ball bearing following this profile. You have to have a piece under here, otherwise the clamps wouldn't have anything to clamp to. 3/8 is about the absolute minimum. If you go thinner than that, you don't get the clamping pressure. But this also means that your router has to come up out of the table to get the job done. And usually 2-piece routers are the ones that you would select for that. Well, those are a few of the work holding and feeding devices that you would use. Let's take a look now at some of the fences that you might find beneficial and talk about some of the features on them. This was used to raise the panel on the arched door or arch door, and I thought I'd flip this up so you could see inside a little bit. This is actually 2 layers of 5/8 inch plywood, and it's like an AC. It isn't real fancy, but we selected it so that it didn't have a lot of voids, and we could have glued a little plug in there if there was a problem, but it was so small it wasn't a problem. On this lower level, we cut an arc out of here, larger than the router bit, and we cut it back at about 30 degrees so that we could put this sheet metal elbow in. Now, the hole wasn't real accurate. On the next level, we cut it not quite as fancy, and this oak piece we cut with almost the same 30 degrees, only on the opposite side. This is glued on, incidentally, and it's just a support. When you look from the back side, you can see the tube fits down in here. These are actually two separate pieces. They started out identical to this, but as we started cutting, we realized that we'd have to separate those to be appropriate for the fit. Now, we also used a material called poly seam seal, which is a caulking material that almost sticks like glue. Once this is assembled, it will hold the whole device together. This poly seam seal comes in a caulk tube. This is about 2 layers on there, and it's about 10 days old. After about 3 days, it's just about absolute strength, and it's one of the materials that works very well for filling those holes and assuring good dust collection. I think dust collection is an important consideration when putting the jigs together. The barrier that I selected for the front of this was designed like a featherboard, and all we did was drill 3 holes and bandsawed to them from the opposite sides. 2 from this side into these holes, 1 from this side into this hole. This gives us some spring effect and a holding action. These are down on hanger bolts, and I talked about hanger bolts earlier, but you may never have seen one, so I thought I'd show you what they look like. A hanger bolt has wood threads on one end, which then goes into the wooden portion, and then it has metal threads that we can use a wing nut or bolt or whatever else we need to hold the stock down. This wing nut makes removal and replacement easy, and that's an important consideration from a safety standpoint. We have to do a layout, and we do all the layouts with the guard off, but we don't make a cut unless the guard's in position. This guard is actually 3 pieces. 2 pieces glued onto this piece of oak, and then this face piece was glued on, being careful not to glue the springing action. If you glued that, it would be kind of pointless. So that's an important feature to think about, and when you plan this out, we then just belt sanded it to a nice uniform shape. So that took care of the raised panel portion of it. Now, when we did the rail, we did essentially the same thing, except our hole is smaller. Remember, the diameter of the cope and stick bits is much smaller than the diameter of the panel raising bit. You can also see that I had to kind of cheat here to fill this area in. I just glued a couple pieces of 1/4 inch on here. And indeed, as you start to make jigs and fixtures for crown doors or arch doors, you're going to find there's a lot of challenges involved. Again, we've used 2 layers of 5/8 inch plywood to make this up. This gives us a total of 1 1/4 inches. This was designed so they'll be high enough to accommodate our workpiece, yet not accommodate our fingers. We also had to be careful of this radius so we could use a push stick to guide around there. And these are all things that you have to think about. Did I only make 1 barrier? I'm afraid I made 3. It takes a while to get things exactly the way you want them, and it's going to take a little experimentation and trial and error. So I'd urge you to be patient, practice this. There's a saying that sometimes it isn't the kill, it's the hunt. Well, in woodworking, a lot of times the jigs and the fixtures are the hunt. Making the door is the kill. It seems simple afterward, but take the challenges as they come and enjoy it. Relax, don't rush it. Things go better if you go easy. Be safe. Let's also take a look at this fence. This one was designed with a couple of other features. Again, we had a wing nut on a hanger bolt over here. And then we had a flathead machine screw holding this in. This is 2 thicknesses of hardwood, solid wood, and it's maple. The upper piece is about 3/4. The lower piece is about 1/2 inch. Why are there 2 pieces? Well, when I made it the first time, I said, gee, there's a lot of space that I could get under there. I want to reduce that space, yet I want to be careful to clear that bit. So I actually just glued 3 pieces on there, and I bandsawed them and routed it off, and that's the appropriate way to put something like this together. Okay, so that's the covering area. The actual fence piece is a piece of oak, very hard material, and it's been rabbeted to the side piece. This is a piece of 9-ply plywood again. I chose that for two reasons: hardness and dimensional stability. Hardness because I clamp it down, I want it to resist those clamps. Dimensional stability, I don't want it warping and twisting. You can see these two pieces are made into an L with a triangular block. They're screwed down. What are they holding down? Well, they're holding this piece of rain gutter or conductor pipe, and there's two sheet metal screws holding that together. I've pushed a 3-inch elbow onto here, and it fits nicely around this rain gutter. And what this allows me to do again is have my dust collection, and this acts as somewhat of a barrier guard over the cutter, and when I add this, I have effectively covered the entire area. Remember, the front of this fence lines up with the ball bearing of the cutter, and I've actually cut that profile to reduce chipping and tear out, and it also reduces the bite the bit takes, and thus reducing the chance of kickback when you're working with these. So these are all things you'd want to factor into this jig should you decide to make it. Now, when you come to other options such as freehand work, these are the devices you need. And then I've got one other device that we use as a barrier. In all the straight line work, you saw me clamp a device similar to this over the actual routing area, so my workpiece went under here. This kept my hands out. If there were a kickback or anything, this is what I would hit. And all you've got to do is make this up. It's a piece of about 1-inch hardwood, routed on both sides, with a profile that will cover the routed area. We've rabbited it, glued it together, and that's holding very nicely. I've used that for about 3 years now on many operations, so it's very safe. Now, when it comes to the freehand work, we're going to be working off the ball bearing of the bit. This larger one was for the panel raising, and we wanted to see the ball bearing, so I put a piece of 1/4-inch plastic up here that's clear. I've actually made a tube or a box that's made up of two pieces of 1.25-inch oak on a piece of 3/8-inch plywood. I have a 3/4-inch piece on here, and this box is all glued together and sealed with some caulking material, again that poly seam seal. This produces a vacuum which pulls the chips away from the cutter. Also notice that I cut this back at a 45 and then dadoed out that area. The reason I did that is I need access to make this sweep on the crowns, and so I had to have that extra space. This one was designed for doing the edges of the rails, the curved pieces, either the crowns or the arc, and with our templates we were able to follow that and make the cut very easily. Again, we had to cut this back so our template would follow through there and not contact it. All of these pieces that are on the edges are made of a harder material. This is, again, a piece of, looks like 9-ply plywood, so when I clamp down on that on the oak, I know I've got strength and I know it's not going to creep. This is beech, one of the very hardest woods on this planet that I know of, at least as far as a domestic hardwood. There are harder, but when I put my clamps on there, I know I'm not going to mash this down and I'm going to hold my stock well. Well, this is a little bit of a preview of what the jigs are like. Hopefully by seeing them, you get a better understanding of what it takes to make doors up. And finally, remember, if you want to be a better woodworker, you got to do more woodworking. Hope to see you on another video. Bye for now. It's good to have a storage place for those expensive bits when they're not in use. In fact, that's kind of why we've made up that nice base and the router table. If you've been admiring these during the course of the video, we'd like to tell you about a set of plans that are available for these. Many of my friends and students like this as well. They asked about the plans, and so we developed a set that are available now. There are 5 pages of prints here and a lot of options that you can use no matter what type of router table you'd like to make up. And there's plenty of opportunities to try your router skills in making this up.